yeah, 10. Really well done with your density last week. Excellent definitions. Very good. I hope you all got my feedback. I did talk last week about the size of Sooty's paws. Now, hopefully you can see him a bit better today. He's got really little paws at the front, and he's got these massive, enormous fairy paws at the back. So this is what we're moving on to next, and we need to find the area of his paws. I did try and put him in some sand earlier to look for the size of his paw prints, but it didn't work very well, did it? No. I'm going to just pop him down, and then we'll have a look at the size of you and your shoe prints and how much pressure you exert on the floor, because that's what we're doing today. Didn't want an escaping rabbit. We talked about last week, density is mass divided by volume, so you had to mass things in grams on the scales. Now today we're going to talk about pressure, which is force divided by area. So that's the first thing we need to learn today, is pressure is force divided by area. Force that I'm exerting on the floor is my weight, so it's my mass times gravitational field strength, and we learnt about this at the beginning of the year. So I've put at the top here, W equals M times G. So if I was to mass myself, I could just use a normal set of scales. So I could put them on the floor and I could stand on them. And I did this earlier and I got 54 kilograms. So I found my mass to be 54 kilograms. So to find the weight I exert on the floor, I would do 54 times 10, which is gravitational field strength on the Earth, and my weight is approximately equal to 540 newtons, because weight is a force that acts downwards. Now, I wanted to go out tonight, so because of the lockdown I couldn't, but I thought I would wear these lovely spotty shoes. Now, or I wondered if I should wear my welly boots, my spotty wellies instead. Now, there's a big difference between the area of the base of my shoes. So now what I'd like you to do at home is have a go at this. You can have a guess at your the force you create downwards, but it must not be your weight. It's got to be kilograms times gravitational field strength. So I did this with my lovely spotty shoes. I got dressed up to come into the garden. And I drew round them on a piece of graph paper or square. You can do anything that you like. And they've got a pointy bit at the front and a tiny heel that you can see at the back there. So I drew round it. And then I approximated the area with a square. And that was 8 centimetres by 8 centimetres, and that was about 1 centimetre squared. So the area that I exert on the floor with my foot is 65 centimetres squared. So if I'm trying to find the pressure, for me, it's the force divided by the area. So my force was 540 newtons. My area was 65 centimetres squared. So you just pop that in your calculator and you get 8.3, but there's an issue with that, because how many shoes do I have? So I have to double it because I've got 4 feet. If I was going to do my rabbit, and on the PowerPoint associated with this, rabbits have got 4 paws. They've got 2 little ones at the front and 2 much bigger ones at the back. So you'd have to work out the total area of their 4 paws. Okay. I asked my friendly helper today to do her shoes. Now, she weighs 22 kilograms, so the force that she exerts on the Earth is 220 newtons, and she put chalk on the bottom of her shoe, and then put a print onto a piece of paper, and we approximated it. Okay, so this is Elise's shoe and Elise's footprint, so you could then easily do yours like this, and work out the force that she exerted. I think she exerts a lot less force in her trainers than I would in my going out sporty shoes. So you need to be able to calculate the force that you exert on the Earth, and then the area that it is spread over, and that will tell you the pressure, because pressure is force per unit area. Now we can measure it in pascals. Units are really important, or newtons per metre squared, or per centimetre squared. It depends what you've measured it in. Now I've put a PowerPoint that will go along with this, and there's a couple of YouTube clips. The first one is about polar bears. And baby polar bears are amazing. Animals are intuitive and incredible. They do something that human babies probably never even would have thought of. And then there's a clip about Icelandic ponies racing on the ice, which is really sad, but none of the ponies get hurt. But there's one pony that's okay. So please watch just the beginning bit of that and have a think about why that Icelandic pony is just fine. Then there's some exam questions, so we learn how to use the skills. So there's an exam question about putting water into a box, and it said what area is it spread over. So you have to try and work it out. All the things are on the PowerPoint, and you have to. There's a bonus challenge question, which is the box of water full? Now you have to remember what the density of water is. So it's 1 gram per centimetre cubed, and 1 litre of water has a mass of 1 kilogram, so it exerts a force of 10 newtons, okay, because it's 1 kilogram times gravity on Earth, which is approximately 10 newtons per kilogram, so it's got an area, a weight of 10 newtons per kilogram, okay, so you can work that out. On the video, there's also some really nice things of animal prints, so if you've got an animal at home, you could have a go at doing theirs. I had a go at doing the rabbit. It wasn't overly successful, but I popped Fluffy, the little rabbit, into a pizza box. I didn't actually put it in a pizza box. It was full of sand, and I have got some paw prints in there which I could measure, and I could put them on my scales. These are about 2 kilograms, it's not very big. So I could find the pressure that he exerts. I would have to remember that he has 4 paws and add up the total area to divide it by. There's lots of questions on the PowerPoint. Please just work through it this week. I will give you some extra questions to do with pressure, but really important. Well done for last week. Density was brilliant. Loads of good work there. Pressure's force over area. Force must be the weight acting downwards if you're doing people or anything like that acting on the earth. Hopefully you'll get this, and hopefully you'll give me some really good feedback. Really well done, Year 10. You're doing a great job, and I will hopefully see you soon. Bye.